In this video, I will show you the most common maximum likelihood estimation question you will get on an exam. And before we start, I would like to tell you that maximum likelihood is a complicated thing. And if you try to learn all of these things today, you will probably feel overwhelmed and feel like this is not possible. So my recommendation is try to maybe learn the first 5 steps today, and then you add on 2 steps every day. And in that case, you have learned maximum likelihood in a few days. And if you have an exam tomorrow and you're studying panically for it, remember that you don't need to learn all the steps in order to score points in the exam. If you can set up the first 5 steps on the exam, you will probably get at least 1 point. So don't be too stressed about the exam. Okay, here we go. Show that the maximum likelihood estimation of a parameter theta is given by the sample mean x bar n. And here we have the probability density function. And the first step we do, set up the likelihood function with probability density function in front of it and I in front of x. So here we have the big L followed by the theta. And here we have the product sign. And this means that every number should be multiplied with itself that comes after the product sign. And we also add an I in front of the x. You can see here. Otherwise, it's pretty much the same number. Step 2. Separate the product symbols into 3 different product symbols. So here we had 1 product symbol, now we have 3 different ones, and we added 1 for each of these numbers. Fairly easy to do. Step 3, replace the product symbols with n and summation symbol. So here we have replaced the first product symbol with squared n and a parenthesis. Here we have replaced the product symbol in front of the e with a summation symbol followed by the number, and anytime you have a product symbol and e after it, you will replace it with this symbol xi. We don't need to replace the product symbol here. This should always remain the same. Step 4, divide n into 2 parts. So here we have a parenthesis surrounding this number and we have 1 n. Now we have removed the parenthesis and we have set up 2 n's. Fairly easy to do. Step 5, set up as logarithm. So here we changed the big L to this logarithm L, and then we added a logarithm and a parenthesis surrounding the entire number. Step 6, separate the numbers and replace multiplication with addition according to the rules for logarithms. So here we have separated the one logarithm into 3 different logarithms. And when we do this, we replace multiplication with addition according to the rules for logarithms. Step 7, remove e and ln. So here we have l and e, and whenever we have this, we can just remove both of them, and we're left with this number here. Step 8, transform division to subtraction according to the rules for logarithms. So here we have changed this number, 2 squared n divided by theta squared 2n, and instead we have logarithm of 2n minus logarithm of theta squared 2n, and this will make it a lot easier to work with this equation. Step 9, move the exponent to outside of the parenthesis. So here we have 2 squared n, and here we have moved the n outside, and then we multiply it according to the rules for logarithms. Here we have theta squared 2n, and here we have moved them outside too and multiply it according to the rules for logarithms. Step 10, move the numbers and the theta symbol out to the summation sign to get theta alone. So here we have the summation sign, and we have minus 2xi divided by theta, and here we have gotten summation sign xi and then minus 2 divided by theta alone. And when it comes to maximum likelihood, you always want to get this alone, because this will make it a lot easier to solve the equation. So remember to keep this in place. Step 11, take the derivative of the function. So here we're setting up this sign here. That means that it's a derivative. And here is the derivative of the number we had beforehand. Step 12, set the derivative equal to 0. So we set this number equal to 0. Step 13, move the negative numbers to the other side. So here we move this number here to this side, and a rule of thumb is to always try to move the negative number to the other side because that will make it easier to work with the function. Step 14, get rid of the denominator by multiplying with whatever number that is on the bottom. And here it's theta squared 2 and theta on the bottom, so we multiply both sides with theta squared 2, and then we are left with this number here. Step 15, transform the summation sign to n times x bar. So this sign here, summation of xi, is transformed to n times x bar. And this is another rule when it comes to maximum likelihood. You should always try to do this, and this is something that you will do over and over again. Step 16, set theta equal to x bar. So here we divide by 2n and 2n on both sides, and then we get x bar equal to theta. Now we have solved the first part of the maximum likelihood equation. Step 17, take the derivative of the numbers a second time. Use the function we had before we set equal to 0. So here is the derivative we had when we derivative one time. Now we're gonna take the second derivative, and this is this answer here. And if you struggle to understand how we derivative this number, you can see it here. This is a rule on how to derivative 2 divided by theta squared 2. And you might have to refresh your derivatives because it's a big part of maximum likelihood. Step 18, replace the summation sign with n x bar. We're doing the same thing as we did before. So here we have summation of xi, and we replace it with n times x bar. And this will make it easier to work with. Step 19, replace x bar and theta with theta hat, and we are replacing two signs. So we're replacing, first of all, this one here, theta squared 2 with theta hat squared 2. We're replacing x bar with theta hat, and we replace theta elevated 3 with theta hat 3. Step 20, multiply the numbers together. So here we essentially solve the equation, and the number we get is minus 2n divided by theta hat squared 2. And final step 21, advocate for that the number is negative and therefore a maximum point. And since theta hat squared 2 must be bigger than 0, and since n must be bigger than 0, and since these numbers cannot be negative, this number cannot be positive and is thereby a maximum point.